Here we go. Proving triangle congruence. So before, what did we have to know in order that two triangles were congruent? What had to be congruent?
The sides.
The sides had to be congruent. What else had to be congruent? The angles. All of the angles had to be congruent to another angle. So here's what's going to happen in this section. So how many pieces of information did you really need to know in a triangle? 1, 2, 3, 4, 5, 6. You needed to know 6 pieces of information. You needed to know that this angle was this congruent to this angle, this side to this side, side to side, side to side, angle to angle. You needed to know 6 pieces of information. Here you're going to learn that you need 3. Do you see SAS? It stands for side, angle, side. You're going to need to know that a side is congruent to a side, an angle to an angle, and a side to a side. And that will be enough to prove that the two triangles are congruent. So in this section, here's what you need to understand. So look at me. There are no numbers in this section. So if you look at me and say, Miss Marshall, I'm really not good at math, you will not be using a calculator at all in this section because there will be no need. All right? So if you follow along, do your notes. We will get through this very well. All right? So first thing we're going to talk about are some terms. Congruent figures. You'll see a blank on your notes. It's a tab. You're going to fill in the said blanks. Congruent figures are geometric figures that have the same size and shape. Same size and shape. Same size and shape. So they have to have all congruent angles, all congruent sides. Here's the next one, rigid motion. You're going to write it down, and then I'm going to explain it to you. All right? Rigid motion, a transformation that preserves length and angle measure. A transformation that preserves length and angle measure. All right, so take a look at my little pieces of paper. Does everyone see them?
Yes. No.
I took 2 pieces of paper, and I lined them up, and I cut out a triangle. Okay? So we would all agree that these 2 triangles are congruent to each other, yes?
Yeah.
Don't be annoying. So they're congruent to each other. So rigid motion says I can move this triangle all the way over here, and are they still congruent?
Yes.
Yeah. I can flip it. Are they still congruent?
Yes.
Yeah. Yes. I could put it all the way over here. Are they still congruent?
Yes.
Yes. So what happens in this section is that we're going to have triangles that have been moved. You could have triangles that are just sitting next to each other. You could have triangles that look like this. They're touched by the vertex. You could have triangles that share a wall. And you're going to be proving whether or not these triangles are congruent. And the way we're going to prove is with side, angle, side. So we're going to talk about it. Before we do, you're going to take out your highlighter. You're going to fill in the blanks and highlight this statement. So fill in the blanks and highlight the statement. In order for 2 triangles to be congruent, all sides and angles must be congruent. So in order for 2 triangles to be congruent, all sides and angles must be congruent. In order for 2 triangles to be congruent, all sides and angles must be congruent. And then I would highlight that whole sentence, because that is crucial to what we're learning. I would also highlight the next asterisk while you're at it. It's what's called a little star thingy. You don't need to know every angle and every side for triangles to be congruent. So you don't need to know every side and angle to know the triangles are congruent.
Which is angle side or side angle?
Doesn't matter, buddy. Just fill in the blanks.
That was my least favorite.
Buddy,
Yeah.
what else would you like to be called? Homie?
Cold.
Home skillet?
I do not like cold.
Please do not say that.
Shepherd calls me bloody. That's the worst thing that's ever happened.
All right, everyone has highlighted 2 sentences? Yes?
Oh, no, I just didn't.
Here we go. We're going to talk about side angle side. So you're going to write in the blank where it says theorem 5.5, side angle side. A lot of people aren't naming it. If you go back to your notes, you're not going to know where it is. Side angle side. We don't call it SAS. We don't call it SAS. We call it side angle side. And I will explain it after you fill in all the blanks. So if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of a second triangle, then the 2 triangles are congruent. So we're filling in the blank right here. If 2 sides and the included angle of one triangle are congruent to the 2 sides and included angle of a second triangle, then the 2 angles are congruent. What word is bolded?
Included.
Included. I'm going to show you what that means. Because does it mean anything to you right now?
No.
Not really. So I will show you. I will show you what included means and show you what's not included. Next to the word included, you can write the word between. So included means between. Not yet. You could write this on the side somewhere if you wanted, but you don't have to. So included means between. So here's what happens. I'll show you a couple different examples of what included means. All right, so what you'll have in these pictures is a side marked congruent to a side. So pretend there's a second triangle. It looks like this one. You'll have an angle marked congruent to another angle. Then you'll have a side marked congruent to another side. This angle is included. It means it's between my 2 sides. Does everyone see that? My angle is directly between my 2 sides. It could be over here. My angle between my 2 sides. So not included would look like this. I have 2 sides congruent and an angle over here. Is this angle between my 2 sides?
That is not.
No, this angle would be in the top. So this would also not be included. So when it says the word included, it's very, very, very important. Ian, it's very, very, very important.
Very.
Because it has to be included. So what I tell people was what I think of. Some people said pizza, which is fine. I think of like ice cream. Like an ice cream cone. All of the information that you need will be in one corner of the triangle. Okay? And it will be enough to prove that 2 are congruent. So we're going to fill in the blank. You see that you have this written on your notes. S does not stand for side. We're going to prove side angle side. So you're going to write this is what goes in the blank. PQ is congruent to WX. So this should go in the blank. PQ is congruent to WX. And then you should mark it on your triangle. So PQ is congruent to WX, and then mark it on your triangle. Yep, in that blank. All right, so then we got side. Now we need to name angles congruent. So in this one, they chose Q and X. So Q and X are congruent to each other. That's the next blank. Fine, I'll look at Mackenzie's. How you doing? Yep, looks good. All right, so mark your angles Q and X congruent to each other. Don't let it be a distraction. Angle Q and angle X. So what sides would have to be congruent? Y'all look. What sides would have to be congruent in order to have side angle side? My angle needs to be included, means between the 2 sides. QS and XY, I agree. So the next one would be QS is congruent to XY. So because of this, you have side angle side, angle, side. Then that's enough information to prove that the triangle is congruent. So that'd be that blank. All right, we're going to talk about a property. It's on the bottom of your page. I have to say it out loud so that we are all on the same page. Yeah, I'll look up here. If this is my wall, okay? Let's say my wall was 20 feet long. Let's just say it. All right? On Mr. Cosen's side, how long would his side of the wall be?
20 feet.
20 feet long, because it's the same wall, right? It's 20.
Oh, 20 feet?
No, it's definitely
20? 20. I would say 20. 30 maybe? Either way. His wall is congruent to my wall. What does congruent mean?
They have the same measure.
Same measure. Why are they congruent to each other?
Because they're touching each other. They're
Same
sharing
wall.
the
It's
same
the
wall.
same wall. So this is called the reflexive property. You'll see it. So you want to write on your paper to remind you of the reflexive property. So remember, the reflexive property is written in bold. Remember the reflexive property. All right, so in this picture that you have on your page as well,
Is that your pencil?
DB is congruent to DB. Okay, so I would highlight what I've highlighted. Highlight the wall that they share, or outline it, so that you can see that the wall they share is congruent to itself. Because it sounds like common sense, but in 2 seconds, it will not be common sense for a lot of people. All right, here we go. So it should say, remember the reflexive property. Reflexive. Here we go. Flip to the next. This is going to be the hardest example. Listen, here's why. A lot of you remember things enough for the test, and then you forget about them and move on.
You're right.
It's hilarious until it's going to come back to bite you in the butt in this section. Okay?
Yes.
So, here's what's going to happen. It says, write a proof. Can someone raise their hand and read to me this sentence? I'm going to pick someone if they know.
Line BC
Okay, Cole.
is congruent to line DA, and BC is parallel to line AD.
How do I know that BC and DA are congruent to each other?
Because it says they're congruent.
What else on the picture? Okay, it told me. All right, and then how would I, not the arrow, how would I know that these two lines are parallel?
Because they have the arrows.
Because the arrows, okay? What am I trying to prove, Kaylee?
Triangle ABC is congruent to triangle CDA.
We're trying to prove that our two triangles are congruent. So does everyone see that we have two triangles? We got one. Here's the second one. All right, so here's what we need to do. What theorem have we learned that proves that two triangles are congruent?
Reflective.
No, the
SAS.
Side, angle, side. Side, angle, side. So we need to find side, angle, side. Side congruent, and angle congruent, and side congruent. So let's look. Go ahead and be writing down everything I write down, because this would be on your quiz. You'll be 3 things. Side, an angle, and a side. You'll be okay. Here we go. Are there sides already marked congruent? What are the two sides that are marked congruent? BC and AD. So we're going to write that BC is congruent to AD. So those are our sides. Do we immediately see an angle? Do we see an angle that is marked congruent? No. So we're going to skip that one for a second just to prove a point. Do we see a side that is congruent?
Yes.
They share a wall.
Congruent walls.
Do they share a wall? Yes. Our wall are. If I have the same wall as Mr. Cosin, they're congruent. This side is congruent to itself because whatever the length is in this triangle, it's going to be the same length in the other triangle. Do we all understand that?
Yes.
So that means AC is congruent to what?
AC.
AC. So if that's the case, in order to prove that these two triangles are congruent, what are we missing?
An angle.
An angle. And this angle has to be included. So our included angle would be this angle in the corner. Do we agree?
Yes.
Yes. So is there something that is going to prove that these two angles are congruent?
Yes. Yes.
All you did was repeat what congruent means.
A and C.
What do these triangles mean?
Parallel.
Parallel. What relationship do these two angles have? They're what? They're alternate interior. What do you know about alternate interior angles?
They are the same.
They're congruent. So that means this angle is congruent to this angle because they're alternate interior angles on two parallel lines. So now, you what? What'd you say?
He said he stood on it.
So when you have two parallel lines cut by another line, what is this lone line called?
Transversal.
A transversal. We just took a test on this 2 weeks ago.
Yeah.
Transversal. We did. Angles that are on the inside of your double lines are called interior. Alternating means they alternate across what line? The transversal. Alternate interior angles are congruent. That's a theorem that you learned. So these two are congruent because they're alternate interior. So we need to name the angles that are congruent. Okay, so we're naming this angle and we're naming this angle. All right, so let's go through. A lot of people would say we would name this angle by C. Why would I not?
That's a side.
Because it's, nope.
No, it's another angle.
It's two angles. That's an angle, that's angle C, this is angle C. So you need to use 3 letters. So what 3 letters make up my green angle here? BCA. So I'm going to say angle BCA is congruent to
BCA.
Or no, CAD.
CAD. Well, technically, angle DAC. If we wanted to be technical. All right, so what letter has to be in the center when you're naming 3 angles, or 3 letters? What is this called? Start with a V.
The bisector.
We should all listen to Wolfgang. What is it? It's called the vertex.
You said it's V.
He said V.
That wasn't very
Well, it's a V. Vertex. Vertex. The vertex needs to be in the center when you name them with 3 letters. So, because of this, this is side angle side. Side angle side is enough to prove that these two are congruent. So you're going to say yes because of side angle side. And you're going to circle all of it. Of side angle side. So yes, they are congruent because of side angle side. I found 2 sides that were congruent, 2 angles that were congruent, 2 sides that were congruent, which is enough for side angle side. This next section will be on the classwork for tomorrow, and it will be on the quiz and the test. We're moving on to the next section. Name the included angle between the pair of sides given. So again, what does included mean?
between.
It means between. All right, so between my two sides. All right, so this would be where you would want to draw on your picture. So we have line JK and line KL. What angle is wedged between them? But I can't call it angle K because how many angles are at K?
LKP.
Angle JKL.
Or PKL.
So pause. Stop saying so many letters. Does P have anything to do with any of these sides?
No.
So we're definitely not using the letter P. So we only have 3 letters left. So we're going to use these 3 letters. And K has to be in the center because it is my vertex with a V. So we could say JKL or we could say LKJ. So make sure you have that written down. All right, now we got LP and LK. LP and LK. All right, so does J have anything to do with my 2 sides right now? No. I need to name the angle between. So here we go. We're going to say angle. What letter has to be in the center? L. So L should not be the first one you say.
PLK.
Yeah, we could say PLK or we could say KLP. But L has to be in the center because it is my vertex. You have to name it like you're drawing it. KLP, PLK. Does that make sense, Tatiana? Okay. All right, you're going to try the last one without me. Go. Here we go. I did record that. We have KL and JL. So this angle is wedged between, what would we call that?
The vertex.
Well, I meant what would we call this angle? What is a vertex?
JLK.
Yeah.
L.
L is a vertex, so we could say JLK or we could say
KLJ.
KLJ. L has to be in the middle. All right, go ahead and flip to the last page. We need to decide if side angle side can be used. We got to hurry because we're running late. Here we go. So here's what I do. This is what you'll have predominantly on your quiz and your test. You're going to compare one triangle to the other. So we're going to compare them. So I usually highlight the one I'm comparing. All right. Do we have a side marked congruent?
Yes.
We do. We have a side. So I'm going to write side, or S, on one of my triangles, the one I've highlighted. Do we have an angle? Yeah, we got an angle marked congruent to an angle. Do we have a side?
Yes.
Yeah, a side that's congruent to itself. So is this side angle side?
Yes.
Yes.
No.
Yes.
No, because it's not.
SAS.
It's not included.
Is the angle included between the two sides?
No. Yes. No.
No, it's not. Side angle side. Listen, Alana. Side angle side. You got it. Apparently. The angle has to be between the two sides. So this one would be no. So the angle would have to be over here. All right, we're looking at the next one. Again, I highlight a triangle or outline a triangle, whichever one I'm comparing. All right, so I have an angle marked congruent to an angle. I have an angle marked congruent to an angle. What else do I have? So I have an angle.
Congruent wall.
I have a congruent wall, which is a side. So is this side angle side? No. Angle side angle, which is a theorem we're going to learn about someday. All right, you're going to need your highlighter for this one. Do we have a side marked congruent to a side? Yes, let me highlight my triangle. So I have a side. Do I have another side? So what am I missing? An angle. Are there any angles that are congruent in this picture? What do we call angles of shared vertex? Vertical angles. What do you know about vertical angles? They're congruent. So this angle is congruent to this angle. So is this side angle side? Yes. Here's what you're going to write down in highlights. So write down vertical angles are congruent. Vertical angles are congruent. And I would highlight it. You will need to know that property. It's not going to be written there for you. You're going to have to know it. All right, we got the last one. I'm sorry we got to speed through this, but we are running behind. We got 10 minutes left, give or take. 14 minutes left. All right, so I'm going to compare the top triangle. Do I have a side marked congruent to a side?
Yes.
Got a side marked congruent to a side. Do I have an angle?
Yes.
Yeah. Do I have another side?
Yes.
Yes. What side is it?
The
The side they share. So is this side angle side? Yes, it is. What'd you say? Was that English to anybody else? Next, here we go. State what information, additional information, is required to know that the triangles are congruent for the reason given. So we're trying to prove side angle side. So we need to look at our picture and see what we're missing. Do we have a side marked congruent? Yeah, we got a side congruent to a side. Do we have an angle congruent to an angle? Yeah. What does this little box mean?
90 degrees.
90. So is 90 congruent to 90? Yeah, so we got side angles. So what are we missing? Another side. So we need to decide if we're going to use...
That was pretty good. That was good.
We need to decide if it's going to be BC or CA. Which one would make our angle included? CA. So we're going to need to have CA be congruent. So we're going to write CA. CA would need to be congruent to what side on the other? LJ. Would need to be congruent to LJ. And that would be our answer. In order to use side angle side, these two sides would have to be congruent. All right, we got our last one. Do we have a side congruent to itself? Yeah, we got the side they share. Do we have an angle marked congruent? Got our 290. Those are congruent, so that's an angle. All right, so what sides would have to be congruent? WV and XK, I agree. So we will say WV needs to be congruent to XK. All right, go ahead and put those away and take